Okay, Unit 5 test review. The first part of this review is talking about those quadratic linear systems. So remember, when we're talking about quadratic and linear systems, you can have two solutions. So that means the line and the parabola cross twice. You can also have one solution, and that's when they would only intersect one time. And then you can also have a situation where they never intersect, and that can be 0 times. So you have 3 types of answers you could have. Okay, to solve these, I could put them equal to each other. So what I'm going to do is I'm going to take each of these equations, and I'm going to set them equal to each other. So that gives me x squared minus 6x plus 9 equals negative x plus 5. Then what I'm going to do is I'm going to set it equal to 0 because I need to factor. So I'm going to add the x over, I'll combine it with the negative 6x, I'll subtract the 5 over, and I'll combine it with the positive 9. So once I do that, these two things are gone. And if I combine everything, I have x squared minus 5x plus 4 equals 0. Okay, so now I'm looking to factor. So I'm going to find out what two numbers will multiply to get 4 and combine to get negative 5. Well, I've got 1 times 4, and I have 2 times 2. If a negative 1 and a negative 4 will give me those two factors. So here I go. So one of my factors is x minus 1. The other factor is x minus 4. I have x equals 1 and x equals 4. All right, now remember though, I'm looking for where they intersect. So what I'm looking for is I'm looking for an ordered pair. The only part of the ordered pair I have right now is I have the x. So what I now need to do is I need to find the y. So I'm going to take each of these, and I'm going to substitute it in for here to find the y. All right, so y equals negative, from the negative here, 1 plus 5. Negative 1 plus 5 is 4. So this one will intersect at 1, 4. I'm going to do it again over here. Y equals negative, but this time I'm going to use the 4 because that's what my x is. Plus 5. That gives me negative 4 plus 5, which is 1. So 4, 1. Okay, I am going to check using the calculator. Remember, you can do that. You can check using the calculator. So I'm going to go to y equals. Okay, and I'm going to put in x squared minus 6x plus 9 and negative x plus 5. Okay, if I graph that, and there it is. So I can tell that there is a solution there and a solution there. So now I'm going to do second, trace, intersect, inner, and there's one of the answers, 1, 4. So that one checked out. That was good. And then I'm going to do second, trace, intersect again. I'm going to move the cursor to the other side of the vertex. And if I keep on hitting enter, I find the other intersection, 4, 1. So use this example to now help you with the rest of that section. So set them equal to each other. All right, the one on the bottom here, again, I'm just going to use the calculator. So it says an eagle standing on a cliff, 12 feet above the ground, saw a ball. The eagle flies downward at a rate 2 feet per second, modeling the equation y equals negative 2x plus 12. The ball being tossed is represented by the following function, y equals negative 3x plus 4x plus 9. Does the eagle intersect the path of the ball before it hits the ground? If so, at what time and at what height? So again, I'm going to go back to y equals, and I'm going to type this in. So negative 2x plus 12. And then I'm going to do negative 3x squared plus 4x plus 9. Okay, so if I graph that, okay, there's my line, and there's my parabola. Now I'm going to zoom in just a little bit. or zoom out actually. Okay, so there it is. And that's my parabola. Okay, so I'm going to do second trace intersect, inner, inner, inner. Okay, and that's what I get. So I get, now that's technically, that's going to be 1. So at 1 second, so this is going to be your time. That's in seconds. So 1 second. And he'll catch it at 9.99. Now that's technically 10. So 10. And that will represent your height. Okay, let's flip it. Alright, on this one here, I actually want to skip over to this. I'm going to do some of these. Okay, so this is that graphing systems of inequalities. So the main thing we need to make sure we remember here is that if the symbols look like this, that's going to be a dashed line. So this is dashed. And if they look like this, it has a solid line under it, so I would make a solid line. Okay. The other thing I need to make sure I remember is that right there, that's going to tell me that it's shaded below because that's less than, so below. And that would be above. So the symbol is just telling me about the line and it being dashed or shading above or below. Alright, I'm going to do number, I'll do number 14. Okay, so on number 14, the first thing I'm going to look at is I'm going to look at this symbol. So again, this is going to tell me that it's going to be a dashed line. It's also going to tell me that I'm going to shade below because it's less than. Okay, I'm going to look at this. That's going to tell me it's a solid line, and I'm going to shade above. Okay, so now I need to look at this for the slope and the y-intercept. So this is my y-intercept. So I'm going to put a point at -1 on the y-axis. Now this just says negative, but I know it's a -1 over 1. So I'm going to go down 1 to the right 1. And again, remember, it's going to be a dashed line. It's a negative slope. Always check your slope. A lot of people get those wrong. So as soon as before you draw that line, kind of picture in your head, is that line falling down? Yes. That means it's a negative slope. Perfect. All right, this said less than, so I'm going to shade below it. So one good way to tell that is if I put my pin on the y-intercept and I move it down, I'm going to shade down here. Okay. All right, now I'm going to do the other one. Again, this is my y-intercept. This is my starting point. So I'm going to put a point at 2. My slope is positive, so 3 over 1. So I'm going to go up 3 to the right 1. And it's going to be a solid line. So let me do my solid line. Okay. All right, now this also is saying that I need to shade above. So I'm going to shade above. Now again, sometimes it can be hard to tell when the slope gets really steep. So again, if you put your pin on the y-intercept, move it straight up. That means you're on this side of the line. And this is my solution area because that's where the two things intersected. Okay, so the point -2, 6 looks like it's going to fall on the line. I'm going to double check it. 1, 2, I'm going to check the slope. 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. Let me see. -2 and 6. Actually, no, that's not going to be it. So that's not a solution. Okay, 0, 0 is right there. That's not in the double shaded. -4, 0 is, so this one's good. 1, 2 is over here. That's not going to work. And then -2, -4, that will work. All right, let me see what's over here. Okay, let's do this. Let's go back to those word problems. Okay, so here what I'm doing is I'm writing a system of equations and finding solutions for each scenario. It says, Mr. Bill went to the farmer's market. At the farmer's market, they had prepackaged fruit baskets. For $21, you could purchase a basket containing 5 pears, 2 mangoes, and 4 avocados. Or 2 pears, 5 mangoes, and 3 avocados. Or 6 mangoes and 5 avocados. Okay, the first thing I'm going to want to do is I'm going to label each variable. I'm going to make my X my pears. I'm going to make Y the mangoes. And I'm going to make Z my avocados. Alright, so what I'm now going to do is I'm going to start putting everything into an equation. So 5 pears, so 5x, 2 mangoes, so plus 2y, 4 avocados, plus 4z, and remember, everything costs 21. I'm going to do it again for the next one. 2 pears, so 2x, plus 5y, plus 3z, and again, everything costs 21. Alright, and the last one says 6 mangoes. Well, hold on, they skipped the pears, so I'm just going to put a 0 there to hold that place. So 6 mangoes, and then 5 avocados, and again, everything costs $21. Sorry, I had to turn the light back on. Okay, alright, so what I'm going to do is I'm going to set my matrix up now. Remember that bar represents your equal sign? And then I'm just going to start putting all my numbers in. So 5, 2, and 4, 2, 5, and 3, 0, because there was nothing there, 6, and 5. Okay, so I'm going to go to my matrix, and I'm going to reset my calculator before I do that. Okay, so to go to your matrix, I'm going to hit second, and then I'm going to hit matrix. I'm going to go over to edit, and I'm going to hit enter. Okay, I always want a 3 by 4, so 3 by 4. Okay, and I'm going to start typing everything in. So everything from the first row. 5, 2, 4, 21. Do it again. 2, 5, 3, 21, 0, 6, 5, 21. Okay. Alright, now I'm going to get out of the matrix. So second, quit. I'm going to go back into the matrix. Remember, it's a whole bunch of in and out. Okay, I'm going to go over to math. Go down to RREF, so the double R one. Okay, so that one right there. Hit enter. Now go back to the matrix and tell them which one to use. So I'm going to use the A, because that's where I put all my information in. So just hit enter twice. And there it is. Okay, so this one did come out as a decimal. So the first one here is going to be the pears. So the pears are, I'm going to round it to $2.33. The mangoes are going to be $2.66. And then the avocados are $1, which is actually the price at H-E-B right now. Okay, alright, let's look at the age problem. Alright, so for the age problem here, it says John, Nolan, and Trevor are brothers. Okay, so I'm gonna make X John, Y is gonna be Nolan, and then Z will be Trevor. Now if I wanted to, I could also use J, N, and T. Okay, so it says John is the oldest and Trevor is the youngest. Nolan is, remember in math, is an equal sign, so Nolan is. So Nolan was Y, so Y is twice as old as Trevor. So 2Z. The sum of their ages, so X plus Y plus Z, is 13. The difference, remember difference means to subtract. The difference between John, who is X, and Trevor, who is Z, is 5 years. Now, if I'm going to put this in the matrix, I need to rewrite this one because all the variables need to be on the left-hand side. So in order to do that, I'm going to subtract 2z, and I'm going to write it in that alphabetical order. There's nothing left over here, so it'll equal 0. Okay, so now I'm going to set my matrix up. Okay, so if I look at this first equation, I don't have an x, so I'm going to put a 0. Y is 1, negative 2, and then 0. Then I'm going to have 1, 1, 1, 13. There's a 1 in front of all of these. I'm going to put a 1 here, 0 here, negative 1 here, and a 5. Okay, at this point, I need to put it into the matrix. So second, hold on. Okay, so now I'm going to put it into the matrix. So second matrix. Oops, let me clear all that out. All right, so second matrix. I'm going to go over to edit again. All right, and then I'm going to hit enter. Okay, I want to keep it as a 3 by 4, so now I'm just going to start typing over everything. So 0, 1, negative 2, 1, 13. Wait, hold on. That needs to stay a 1. So 1, and then 13, and then 1, 0, negative 1, 5. Okay, so out of the matrix, go back into the matrix, go over to math, go down to that ref again. You can also get to it by doing alpha apps. And hit enter. Now go back to the matrix and tell it to use A. So enter, enter. I can tell something's not right there because I don't think the ages are supposed to be that way. So I'm just going to go back to my matrix just in case and just make sure I put everything in correctly. There it is, 0. But that's it. But I'm going to double check everything else. Okay, that worked. 1, 0. Okay, now it should work. All right, so we'll do it again. Second quit. Second matrix. Go over to math. Go down to B. You can also get to it by doing alpha apps. If you go over to matrix again and hit enter twice. And that looks a lot better. So John is 7. Nolan is 4. And Trevor is 2. Okay. All right, so down here they want us to solve this one using the calculator, so using the matrix. This one's already kind of set up for you because if you'll notice, all the variables are on the left-hand side, but this one is not. I have this plus 3x over here, or I'm sorry, plus 3y. And I also have, over here, I have everything on that side. That one's all messed up. And then I also have everything on this side. So what I'm now going to have to do is I'm going to have to rewrite this so that I can put it into the matrix. So I need to get all the variables on the left-hand side. So I'm going to do minus 3y here, which means I have to do minus 3y here. And then I'm going to rewrite all this so that it's in alphabetical order. So 4x minus 3y plus 2z equals 12. Then I'm going to need to move this. I need to do minus 3x minus 3z. Again, put everything in alphabetical order. So negative 3x, positive 2y, minus 3z equals negative 5. Again, I'm going to subtract the 2x, and I'm going to subtract the 7z. Okay, so that would be negative 2x, again alphabetical. The y would be next, so plus y, because it's positive, minus 7z equals 8. Okay, so now that all the variables are on the left-hand side, I can now set up my matrix. Okay, and then once I do that, I'll put it in the calculator. So go back to the matrix. I'm going to edit it. Okay, I'm going to start typing over everything. So 4, negative 3, 2, and 12. Negative 3, 2, negative 3, negative 5. Negative 2, 1, negative 7, and 8. Okay, I'm going to get out of the matrix. Go to math. Enter. Oh, I made a common mistake here. Got to get out of it. Got to get out of it. So let me get out of there. All right, now go back to the matrix. Again, I'm going to do alpha apps to get to it. Go to the matrix and hit enter twice. And that's my answer. So x equals 1, y is negative 4, and z is negative 2. And again, I can write that as an ordered triple. 1, negative 4, negative 2. X, y, z. Okay. All right, let's look on the back here. So this is writing systems of inequalities. I would say the most important symbol here is at least. You've got to make sure you understand that at least is greater than or equal to. You have to be at least 18 to vote. So equal to 18 and greater, you have to be at least 48 inches to get on most roller coasters. So 48 and greater. All right, so this one says the girls' swim team is hosting a fundraiser. They would like to raise at least 500. So again, at least 500. They are selling candles for 5. I'm going to make candles, I'll just keep it a C, and flower arrangements for 6, so F. The girls estimate that they will sell at the most, so less than or equal to, 200 items. All right, so this is my equation that's going to be all about money. So they tell me that the candles are going to be $5, so 5C, plus the flower arrangements are 6, so 6F. So there it is. That's that inequality. Okay, now I'm going to do the second one. Now, what are they selling? This one can be a little difficult because they just say they will sell at the most 200. Well, what items are they selling? Oh, yeah, they're selling candles and they're selling flower arrangements. So that would be the two equations. All right, the next one, this one's definitely on the test. Please make sure you know it. So this one says Jessica has a job babysitting, so I'll use B for that, and pays $9 per hour, and a job walking dogs, so I'll use D, for 5 hours. She wants to earn, again, there it is, at least, make sure you know it's greater than or equal to, $120 next week to pay for her prom dress. Her mom said she cannot work more than 20 hours so she can have enough time to focus on school. Good job, Mom. All right, so here, again, I can tell I'm going to have an equation that's all about the money. So she does $9 for babysitting, so 9B plus 5D, and again, that at least greater than or equal to $120. Now, the other one just says she cannot work more than 20. So she can work 20, but it has to be less than that. So less than or equal to 20. And again, this one can be difficult. What does she work doing? Oh, yeah, she babysits and she dog walks. Okay, all right, let's take a look at this one. Y'all did really well. So on these, y'all, you want to make sure you start with the smallest, then you go to the medium, and then you go to the large, okay? So it doesn't matter what order they're in. You always start with the smallest, the medium, and then the large. Okay, so let's take a look at number 21. So this is my smallest one, so I'm going to start here. So R equals 5. This is my medium one. Excuse me. So I'm going to take that R, I'm going to substitute it in. So 2 times 5 minus 6u equals negative 14. That gives me 10 minus 6u equals negative 14. Minus 10 minus 10. That gives you negative 6u equals negative 24. Divide by negative 6, divide by negative 6, u equals 4. Okay, now I'm going to go to the largest one, so this one right here. So that gives you 5 minus 3s minus 2 times 4 equals 6. So 5 minus 3s minus 8, because negative 2 times 4 is negative 8, equals 6. I'm going to combine this and this. That gives me negative 3 minus 3s equals 6, plus 3 plus 3. Negative 3s equals 9. And when I divide that, I get s equals negative 3. All right, so here's what I'm going to do, though. First of all, I'm going to write it as an ordered triple, so alphabetical order. So R would go first, R, S, T, and then U. Okay, so that's my ordered triple, but now I'm going to check my work. So I'm actually going to come back up here, and I'm going to substitute every variable I know, and I want to see if it's going to equal 6. So R was 5, so 5 minus 3. My S was negative 3, minus 2, and then the U is 4. Okay, so if I come here, I'm going to type all that in. So I have 5 minus 3 times negative 3 minus 2 times 4. And yay, it equaled 6. So I know I'm correct. Okay, that should be it. If you have any questions, please make sure you talk to your teacher. Make sure you study, especially these. Remember, you can also always check these in your calculator using second trace intersect. The most common mistake on this one, y'all, is people stop right here. But that's not good enough. I'm looking for an ordered pair. I'm looking to see what point it crosses at. Okay, remember, points have X's and Y's. All right, good luck.